Okay. Good afternoon, fellow primates. My name is Stephanie Canington. I'm a research student in the Division of Mammals and a PhD student studying functional anatomy and evolution. Today I'm going to share the story of one juvenile orangutan with you. Earlier this year, Dave Hunt and I published an account on an orangutan specimen that was somewhat famous in the Division of Mammals for its unusual pathological appearance. We often refer to the individual as the pathological orang, but we didn't want to leave him like that. We wanted to know what happened. Specimen USNM 296650 is a skeletal-prepped juvenile male Pongo pygmaeus. He was purchased in northern Borneo in August 1952 and was delivered by ship to the National Zoological Park. Records show that he died 4 months later. It's important for researchers to understand the normal life patterns of the animals that they study, especially great apes, because great apes are incredibly diverse in their locomotor repertoires, ages at weaning, and ecological niche specializations. It's with some knowledge of the norm, be it diet, exercise requirements, or parental care, that we may consider implications from abnormality in making our diagnoses. So getting back to the little guy, I'm going to talk about the pathologies of his skull, most notably the bilaterally enlarged mandible and maxilla. Here, extensive osteoclastic resorption left the elements brittle and unable to contain postcanine teeth. The mandible exhibits the most severe degree of deossification, and the coronoid processes are just gone. Postcranial elements are nearly equally afflicted. The ribs are significantly bent inwards at the shaft, and vertebral elements are extremely porous. In fact, the degree of porosity actually increases as we move down the vertebral column. All long bones suffered extensive loss of density, and the left tibia exhibits a very slight, possibly pathological curvature. My guess is that the orang was mostly sedentary. It would have been very difficult for him to support his own body weight. Though commonly documented in humans, metabolic diseases have been reported in a number of species, including captive primates. Up until the mid-20th century, zoos were often unsuccessful in establishing proper housing conditions for primates, who found themselves lacking necessary stimuli, adequate diets, and sunlight exposure. Disease transmission was an additional concern. A comprehensive literature search on the metabolic diseases of captive primates became the basis for our suggested diagnosis. After lots and lots and lots of digging, we began to put together a differential diagnosis, including 2 alternative hypotheses for the bilateral expansion of the jaws. So it's really important to look at the specimen and see that it's not localized. The pathology is everywhere. It's spread throughout his entire body. So we knew that it wasn't some simple infection caused by a cut on the ship. It was something more severe. So by comparing osseous pathologies seen in other species, we believe the most likely diagnosis to be a metabolic disorder called secondary hyperparathyroidism and accompanying fibrous osteodystrophy. Secondary hyperparathyroidism is a disorder caused by the excessive secretion from the parathyroid glands. These small glands are responsible for the calcium homeostasis in the body through their production of parathyroid hormone, or PTH. Accompanying this is a disorder of osteoclastic resorption of the bone and a subsequent replacement with fibrous connective tissue. The relationship between the resorption of vitamin D3, ultraviolet B light, calcium, and phosphorus in the body is a complex but really important system. It can be thrown out of sync due to inadequate nutrition and sunlight deficiency. When the system is affected, secretions of PTH have 2 main mechanisms by which to increase the circulating calcium levels. By acting on the bone, breaking it down from its storage of calcium, and by acting on the kidneys to reduce the amount of calcium that actually leaves through urine. So it's with a consideration of metabolic physiology, the specimen's age, trauma from transport, and its captive status that we believe our proposed diagnosis is further supported. Today, experts on the nutritional requirements of primates, like those working at our very own NCP, have made incredible progress in maintaining the health and welfare of these wonderful animals. And I am so grateful to everyone in the Division of Mammals, especially Darren Lundy, Obviously, Dave Hunt, the co-author and skeletal biology expert on this project, my graduate advisor, Jonathan Perry, Ethan Rogers, and everybody who came out. And I have enough time to mention that orangutan means person of the forest. So, thank you. I'm sorry my voice was trembly. Okay, so I'm Stephanie. I've been around here for many years. You can't get rid of me. I've been in the Division of Mammals, Darren Lundy's student for years, learning everything about collections management and going out in the field, studied chimpanzees in Africa, did paleo field work. New science is the best thing in the world, and I've always wanted to work in museums, so this is the best place for me to be, and I got to work on this awesome project, one of many awesome projects that are available for interns. Take advantage of your internship, get involved in research, and talk to curators. They're not scary. They trust me, they look scary, but they're not. And there's nothing a scientist loves more than talking about his or her own research. So really, take advantage of being here. Go to as many talks as you can. It'll be one of the greatest experiences of your life. So,
Stephanie, you're a PhD student at Johns Hopkins in Baltimore, and you're down here working on the collections. What's your average day or week like? I mean, do you spend more time here or there? I'm sure that students would like to know about how do you work that?
Well, I guess my average day is a little different because I do a lot of human dissections. First year of, are the interns here in high school, undergrad, grad school, a mix? Undergrad? Awesome. Yeah, so have a lot of fun, like learning about science. Grad school. I don't know, you go into grad school because you want to learn about science. If you go into grad school for science, you want to learn about what you're doing. So get there early, do coursework, stay late, maybe dissect a person, maybe not. First year is hard for doing other stuff, like coming here to do extra research. So you have research that you're expected to do for your courses, and then you have extra research you do for your own sanity, because it's fun. I've had to come in mostly on weekends to do a lot of this, and this project happened over the course of a year, so it takes a while. But yeah, grad school is tough. It's tough. It takes a lot of time, but if you want to do it, it's worth it. I don't know if that answered any question. Or,
I was just curious what the ultimate goal of the research on that particular ape was. Like, was it hoping to improve conditions in zoos, or was it hoping to expand on medical knowledge?
So actually, this kind of thing doesn't really happen anymore because zoos are fantastic in taking care of their animals, especially our zoo. Well, we're a little biased, but our zoo is fantastic, and they take very good care of our animals. So it's over the past half century, people have learned that there are correlations between diet and activity patterns and kind of what's encrypted in the species genetically, because orangutans are different from chimpanzees, which are different from humans. So we all have our different ways of living, and we all need different things. We eat different things, and we have different activity patterns. So by understanding what's the norm for that particular species, we've been able to understand how to better improve zoo conditions. So this really was just, hey, there's this really pathological orang in the collection, let's see what happened. But it actually has turned into a project that I'm working on right now that I can't really talk about, but it's actually expanding on. So it's pretty cool. Yeah, so take advantage. If you see really weird stuff, ask the curators, like, hey, did you know this was a thing? Can I publish on it?